Okay, so we are going to look at covalent bonding today. Okay, page 41, 41. Okay, let's make that bigger. We do not need closed captions because there's actually no talking in this one. Everything is going to be written out for you. Okay, here we go. It is a little weird. I'll warn you right now.
Huh? Huh? Oh.
So you can fill in that first little paragraph there. Noble gases have complete outer electron shells, which make them stable.
Oh.
Okay, so we can fill in the second paragraph. In order to get this kind of stability that we have with the noble gas, other nonmetal atoms come together to achieve this noble gas configuration. Okay, so you're filling in the second paragraph, noble gas configuration. Okay, we are on page 41 for one. Okay, so here we can fill this in. This coming together and sharing of electron pairs. So this coming together and sharing of electron pairs leads to the formation of a chemical bond known as a covalent bond. And we're on page 41. Okay, we're going to go back because I think we missed something. Let's just see. Or maybe we didn't. Okay, so at the bottom of the page, here, each chlorine atom has how many electrons? 7. In its what shell? Outer shell. What is another word we could use for outer shell? Valence shell. It needs one more electron to attain stability. In other words, to complete its, and here's a new word, octet. Do you guys know the meaning of the prefix oct? 8. Okay, so if you have an octet, you have 8 electrons. Okay, on to page 42. Okay, 2 chlorine atoms come together and what do they do with their electrons? They share their electrons to form a molecule of chlorine. Okay. Okay, in this way, each atom will have 8 electrons in its valence shell. Okay, a single pair of electrons, you can see right here, we have 2 of them that are contained by both atoms. A single pair of electrons is shared between them, and that bond is known as a single covalent bond. So the first 2 blanks, we have a single pair of electrons, and that is known as a single covalent bond. Let's see if we can fill these in before the little story tells us. A single covalent bond is represented by a single line. So if I have Cl, I'm going to draw a single line, and I'm going to draw the other Cl. Take a look at the oxygen atom. How many electrons are in the valence shell of oxygen? 6. So it needs how many more? It needs 2 more to complete its, and the new word that starts with an O is octet. Octet means a group of 8. Who do you think it's going to share 2 of its electrons with? Another oxygen. But it could also share it with other things. But in this case, we're going to look at oxygen sharing with oxygen. Okay, this one's kind of funny. Let's get it back here. Yeah.
Oh.
I'm sorry, Tristan. Okay, so we can fill up at the top. We have an oxygen molecule. So you can fill that box in at the top of page 43. And then we have when 2 oxygen atoms come together, they each share 2 electrons to complete their octets. All right, and since they share 2 pairs, how many is 2 pairs? 2 pairs is 4. 2 and 2, 4. Since they each share 2 pairs of electrons, there is a double bond between the oxygen atoms, and you can draw it like this because that's kind of covered up. You'll have an O, and then 2 lines, and another O. Okay, that's a double bond. That's 2 electrons in one line and 2 electrons in the other line. So you can fill in those little things in the picture. It says 2 pairs of electrons, double covalent bond. Yes.
On page 42.
Oh, yeah. The bottom of the page?
No, the photo on the top.
Oh, the photo at the top of the page of 42? Let's take a look at that. Make sure we all got that. Yeah, I felt like maybe we hadn't gotten that. So here's chlorine and chlorine. Let's fill that in. This is on page 42 at the top. We have a chlorine molecule. And we have 1 pair of shared electrons. And then underneath that, one pair of shared electrons is a single covalent bond. Are there any other things that anyone missed that we'd like to fill in? Okay.
Good eye.
Hmm. Hmm.
Okay, so here we have a nitrogen molecule. And here it says, similarly, two nitrogen atoms share a triple covalent bond to form a molecule of nitrogen. And a triple bond looks like this. Oh, come back. No, go back.
In this video,
We don't want to learn about fractions. No.
Yeah.
No. Ah. There we go. All right, so on page 44, you can fill in the top. In a nitrogen molecule, we have 3 pairs of electrons. 1, 2, 3, 4, 5, 6. And that forms a triple covalent bond. And just a reminder to anyone who is interested, we do have enriched bonding stuff should you be interested in such a thing. Okay, and it is to do with drawing these kinds of diagrams. Okay, so if you don't have that and you want it, it's right there. Okay. So what you're going to do right now is you're going to finish up the questions on page 44, and then we're going to take a look at page 45 and onward, okay? So take a look at page 44, and then together we'll do page 45, etc. There we go. Okay, so the ionic bond, the metal gave its electron to the nonmetal, making the metal positive, and the nonmetal negative, and then the two of them stuck together. And if you remember the word electronegativity, anyone remember that? Electronegativity. Metals don't have very high electronegativity. Their electronegativity is really low. So they tend to give away electrons. Nonmetals, their electronegativity is really high, so they tend to take electrons. But what's going to happen If you have two things that have similar electronegativity, I need a volunteer from the audience. Volunteer.
Seven, go.
Yes, Armando, come on. Okay, we're gonna close this so we don't get blinded. All right. And you are going to be fluorine for now. Okay, fluorine. You're gonna hold up your electron. This is his electron. All right. He has 6 other electrons. That's the 7th electron, and you're gonna hold out your other hand because the 8th electron, there is a gap. Good. Now I am sodium, and I have 1 electron in my valence shell. I am not very good at holding on to electrons, but he's really good at grabbing electrons. He's really good at grabbing electrons. Yes, that's ionic. Yeah? But what if, instead of me being sodium and you being fluorine, what if we were both hydrogen? Then we're both equally good at pulling electrons towards ourselves. Yeah? Nucleus. Excuse me. Nucleus, positive, yes? Nucleus, positive. Electron, what is it? Positive or negative?
Negative.
Electron, negative. And remember, we're both just as good at pulling on electrons as each other. You're going to grab this one like that, and we're both going to pull. Okay? So we're both pulling on those electrons, and that's what holds the 2 atoms together. Got it? I would like you all to try forming a covalent bond. Thank you, Armando. So find a partner, form a covalent bond, and what you're going to be doing is you're going to be pulling. Okay? And so one of you go pair up with Jazz. Go form a covalent bond. Yeah. I don't care what you do. Yeah. Wait, 2 seconds. Where are your electrons? You have an electron. There we go. Good covalent bond. Okay, show me your covalent bond. No, she has an yes, very nice. Okay. Yeah.
Oh, are you using bonding or I don't know.
Whatever.
Wait, oh. Hold on. Wait. Okay, wait. Okay, stand up and you do it.
There we go. Okay, now we'll pull.
Oh,
That is a cool.
yeah, would you like to do
Ryan, show me your covalent bond.
So the thing is, so you got it.
Okay, Ryan, I don't know what you got.
You jumped in time. You grab 4, we grab 1.
You're a hydrogen. Both people equally. Make it equal, make it equal. Because you're positive, you're negative. You're positive, you're negative. Show me your Covalent Show me your Covalent Did you see what I did with that one right there? Okay,
I'm sorry.
this is your 11th time. Oh, and now your 11th. Now, you're going to be their 11th. I know. And now, that one. So you're pulling on the equally. Okay, and that's a good No, it's show me your Covalent. There we go. I got Calm down. Calm down. Okay, sit. Now, what you guys just demonstrated is that when, say, we have a hydrogen atom and another hydrogen atom, when they share their electrons, the positive nucleus pulls on the negative electrons. And on the other side, the same thing happens. That positive nucleus pulls on the negative electrons, just like both of you, all of you guys were pulling on the pens, and the other person was also pulling on the pens. And the reason that they share rather than give and take is because they are both just as good at pulling on electrons as each other. Does that make sense? Metals are terrible at pulling on electrons. So if a metal's around, it's like, here, just take my electron. But if you get a non-metal and a non-metal together, they're both trying to pull on the electrons, and so they end up sharing. Now, if we were really a little bit more honest about what it looked like, it would look a little bit more like this, because this is the electron cloud model. You would just end up with electrons. You remember how we had like the electron cloud for an atom, and the electron was found within the cloud? Well, that's what the cloud looks like for a molecule. Yeah? You don't need to worry about that too much, though. This just shows the attraction between the nucleus and the shared electrons, like we were just talking about, because positive attracts negative. Okay, next page. You can read this electronegativity thing if you want to. This is enriched. But almost all the time, when you have covalent bonding, you get molecules. So here is a hydrogen atom and a hydrogen atom. Each of them have one gap in their outer shell. So what can they do? They can share, and that gives each hydrogen 2 electrons. How many electrons fill up shell number 1? 2 electrons fill up shell number 1. Fluorine, and you'll notice we have stopped drawing the inner shell. We are only drawing the outer shell. Here we got a gap. Here we got a gap. What can they do? They can share. How many shared electrons are there? 2 shared electrons. How many pairs is that? 1 pair. Is that a single bond, a double bond, or a triple bond? That is a single bond. And if we wanted to draw it, we could draw it like this. F with a single line and then another F. And that is a fluorine molecule. How would we write the formula for that molecule? Absolutely. F2. Where does the 2 go? Top or bottom? Bottom. Good. Now let's take a look at carbon dioxide. We got 2 oxygen atoms, and I've drawn it a little bit differently so you can see that there's like a total gap here. Yes, we got a gap where we could have 2 things. And you know who could come in and share with oxygen? That carbon could go. What?
There's 2 oxygen.
Oh, there's 2 of them. That's why. Okay, it was making me very unhappy. Okay. At any rate, we have oxygen sharing its 2 electrons with carbon, and carbon sharing 2 of its electrons with oxygen. And that gives this oxygen here 1, 2, 3, 4, 5, 6, 7, 8. Is that stable? Yes. For carbon, we also get to include all the shared electrons. So if we count them out, we can say 1, 2, 3, 4. And then on the other side, we have 5, 6, 7, 8. So carbon also has 8 electrons. And then finally, our oxygen on the other side has 2, 4, 6, 8 electrons. Everybody has a complete octet. Everybody has 8 electrons. Yes? How does carbon monoxide look? That's a really good question. I'll show you in just a minute. Okay? Just before we show carbon monoxide, let's take a look here. How many shared electrons between carbon and oxygen? 4 shared electrons. How many pairs is that? 2 pairs. And what kind of a bond do we call that? That is called a double bond. So if we were to draw this molecule, we would put carbon in the middle, 2 lines here attached to oxygen, and 2 lines here attached to oxygen. And when you get into grade 10, you'll learn that you also want to draw in those non-bonding electrons as well. Okay, but you don't have to worry about that for this year. You can just draw the bonds in, okay? All right, and you wanted to know about carbon monoxide. Let's grab I'm just going to grab a blank sheet of paper for that. Okay, so I've got carbon. Carbon has 4 valence electrons because it's in group 14. Oxygen has 6 valence electrons because it's in group 16. Okay? So really what we have is we have 10 valence electrons to work with. All right, we're not allowed to have less than 10. We're not allowed to have more than 10. That's how many we have. So far, so good? Okay. So we have 10 valence electrons. All right, let's start by drawing carbon here. And it has 1, 2, 3, 4 electrons. And we have oxygen here, which has, and I'm going to draw these in red, 1, 2, 3, 4, 5, 6 electrons. I've gotten rid of the circles because I forgot that I'm doing this with grade 9s. So I'm going to put the circles back in. Sorry. My grade 11s are doing this right now too, but we just get rid of the circles. Okay, so there's our circle. Oxygen. There's our circle. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. We're going to start by having carbon and oxygen share that pair that I've highlighted in yellow. And we're going to start by having it share this pair that I've highlighted in blue. This is not going to fix everything, but it's a start. Okay, so now what we have is we have carbon, and in between we have 1, 2 from the carbon, and we have 1, 2 from the oxygen. That one's red there. Okay. So far, so good? Now, if we look, oxygen still has 1, 2, 3, 4 unshared electrons. And carbon has 1, 2 unshared electrons. I'm going to draw them together because electrons don't like to hang out in an unpaired fashion. They will pair up in molecules all the time. Okay, they won't stay like separate. Okay. Now, if we count up the electrons for oxygen, 2, 4, 6, 8. Oxygen is okay. But carbon only has 2, 4, 6 electrons. And that is not okay. Who could be generous and help carbon out? This oxygen can actually say, hey, why don't I move these ones into the middle as well? So instead of just giving in 2 of my electrons, I'll put in 4. Okay? So now what we have is we have in the middle 2 electrons from carbon, which are black. And then we have 1, 2, 3, 4 electrons from oxygen, which are red. And I'm kind of running out of room. We got carbon over here. We got oxygen over here. We still have these 2. These ones have moved into the middle, so we don't have those anymore, but we still have this pair over here like that. So what that means is now we have a carbon. What kind of a bond would we have here? How many shared pairs? 3 shared pairs, 2, 4, 6 electrons, oxygen, lone pair, lone pair. Okay, that's beyond what you need to be able to do for grade 9. Okay, so don't worry if you were like, what just happened? Okay, but if that was interesting for you, take Science 10, Chem 11, and you'll get into more of that. And also the enriched stuff has a little bit of this in here as well, okay? All right, let's go back to here. Go. Now you can have some complicated stuff. You can say, oh, I've got carbon and fluorine. Now carbon has 1, 2, 3, 4 gaps. Fluorine only has 1 gap. So in order to satisfy carbon, you will actually need 4 fluorine atoms to come in and share to give carbon a full 8 electrons, a complete octet. Is good? So let's redefine molecule for ourselves. We mostly know this. We've talked about molecules already. Molecules, what is their charge? What's the charge of a molecule? Neutral. Okay, so they are electrically neutral. How many atoms in a molecule? 2 or 3 or 4 or 5 or we could just say 2 or more, okay? There's 2 or more atoms. But not just any old atoms. What type of atoms form molecules? Nonmetals. And what holds those atoms together? Covalent bonds. So here's a question, discuss with your neighbor. Why does a formula unit not qualify as a molecule? First of all, what is a formula unit? Tell your partner, what is a formula unit? What is a formula unit? What kind of bond do we have in a formula unit? An ionic bond. What kind of bond do we have in a molecule? Covalent bond. What kind of atoms are these? What kind of atom is the positive one? That's a metal. And the negative one is a nonmetal. In order to be a molecule, what types of atoms do you have? What types of elements? Nonmetals only. So why is a formula unit not a molecule? Because it has metals and it has an ionic bond, not a covalent bond. Okay? All right. And also, a formula unit is made of ions, not atoms. Molecules are made of atoms. Do you know what I mean when I write MC? MC means molecule. Okay? Okay. This basically just walks you through what we just talked about there, so I'm not going to read through it. Okay? So we're now on page 48. Okay. The number of holes in the valence shell generally determines how many bonds an atom will form. So how many holes are there in hydrogen? One hole, one gap. One gap. Therefore, it's going to form one bond. How about carbon? How many gaps are there in carbon? 1, 2, 3, 4 gaps. So if you look at how these slot together, we end up with these guys, these 2 electrons pairing up, these 2 electrons, these 2 electrons, these 2 electrons. So if we were to draw it over on the right-hand side, we would have our hydrogen here, our hydrogen here, our hydrogen here, and our hydrogen here. What would that look like if I wanted to just draw the letters and the lines? Who would go in the middle? Who goes in the middle? Carbon goes in the middle, and we attach it with a single line to hydrogen because they share one pair of electrons. We attach it with a line to hydrogen because that is one pair of electrons. And we attach it with a line to another hydrogen because that's one pair. And we attach it with a line to another one. That's one pair. Now, if you are interested in rich stuff, this molecule here is known as methane. The prefix meth means that whatever molecule it is contains one carbon. So if you have methanol, that's an alcohol that contains one carbon. If you have ethanol, that contains 2 carbons, but it's also an alcohol. Okay, that's a little bit of organic chem there for you. How many gaps in nitrogen? 3. 1, 2, 3. And of course, hydrogen each has 1 gap. So they can then share. Hydrogen's going to share its electron here. Hydrogen is going to share its electron at the bottom. And hydrogen is going to share its electron over there. How would we draw the line structure for this? Who goes in the middle? N goes in the middle, and we attach it with hydrogen and hydrogen and hydrogen. And if we're in grade 10, we put a lone pair up there because that's a non-bonding pair. This is called, anyone know what NH3 is called? Ammonia. Okay, and I forgot to put methane up here. Methane is, its chemical formula would be CH what? CH4. Okay, so you can learn the name ammonia if you want to is NH3. Methane is CH4. How much time do we have left? Like hardly anything, right? 53. Okay, so we're just about done here. So I'm just going to assign you for homework. Page 54 and 55. Okay? And if you don't know anything in there yet, don't worry, we'll get to it next day. If I miss something that we haven't covered yet. Thank you guys for your patience with that long lesson. Yes. Pardon me? Oh, you don't have to do the enriched stuff. No. No.
So it's like covalent bonding and covalent bonds are the same.
Yes. Yeah.